So yeah, this is the first question. Today we are dealing with multiple random variables. Um, yeah, so this is the first question. X is a continuous type of random variable with this period. Right. Uh, so fx is 0 if it is negative, and it is half. Remember, this is density. Um, it is half from 0 to 1, and it is 1 over kx square when x is more than 1. Okay, so the question is, you made a transformation on y as 1 over x, sorry, on x to get y, that is y is equal to 1 over x. So what is the density of y, the new random variable y? This is exactly 1 over x. So the solution is very straightforward here. I mean, if you observe, right, so negative, this transformation doesn't change negative to positive, positive, negative, right? If x is positive, y is positive, x is negative, y is negative. So negative side, if you see minus infinity to 0, it is 0. So the same holds here. When y is less than 0, it is 0. And so the roles of 0 to 1 gets reversed in when you take 1 over x. So when it is 0 to 1, 1 over x varies from 1 to infinity, right? So that precisely you get this because y goes from 1 to infinity when x is from 0 to 1. So you get exactly half. And the role of 1 to infinity reverses to 0 to 1, right? Because we are taking 1 over x. So that's why you get 1 over 2y square. How we get 2y square is very simple. So, yeah. Okay. This is it, right? So because it is density, it should be integrable to 1. And when you do the integration, you get k as 2. Okay, so this is whatever I've just explained, I just put it down. Okay, so yeah, that is very simple. Any questions on this? If not, we can move to second question. So for second question, are you familiar with convolution? I just wanted to ask because it relies on that. Have you heard about convolution? Yes, yes. Okay, so okay, I'll let me let's go to the thing first. Okay, so you have x and y ID uniform random variables. That means 0 to 1 is distributed with mass of 1 aggregate between 0 to 1. Now they want you to find the expected distance between x and y. So distance between x and y in real line is nothing but mod x minus y. Okay, and the standard deviation of the distance between x and y. So distance is mod x minus y. So distance involves two random variables. The distance itself is random variable. So they want the mean and standard deviation of that random variable. The question is clear, right? Distance is mod of x minus y. X and y are uniform random variables. Okay. So x and y are uniform, 0 to 1. If say y is uniformly distributed from 0 to 1, minus y is also uniformly distributed between minus 1 and 0. Right? You just change the sign of the value that you got. Okay, so x minus y you can write as x plus minus y. So I am sure you would have read in the lecture notes, right? So if x and y are independent, then the sum distribution of this sum is the convolution of the distribution of x, and sorry, the density of x plus y is the convolution of densities of x and density of y. So this is why I wanted you. I just asked, the convolution operation. Okay. Basically, x is lying from 0 to 1, and y is, sorry for the typo, it should be somewhere between -1 and 0. Okay, the density of y, -y, sorry. So when you add it, right, the convolution of two functions, right, will be something like this, right? The support will be -1 to 1, and um, this is 1. Because it is density, its area should sum to 1, right? So this is a triangle. This area of this triangle is 2. Sorry, 1, right? Half times 2 times 1. Okay. So this part is important. If you want me to iterate, I can write it again. Yes, yes, exactly. You can solve the relation between x and y. So assume you have x and y, some independent random variables. Okay, now you add it. You can show that z is the convolution between x and y. And by doing that operation, you get the triangle out of those two squares. Okay. So for now, let's take that and that is true. And after we complete all these questions, I'll quickly derive that. Okay. Um, can you guess if z is x minus y and its distribution is like this? What would be the distribution of mod z? Any wild guess? May not be correct, but yeah, I mean, you should be able to get that. Um, how that will look like, the density of mod z, right? Any answers? Okay, so see, because z, okay, cool, no worries. So the first thing to guess is, see, mod z, the range of mod z, right? Is z is taken from -1 to 1. Mod z will be from 0 to 1, right? And let's say if another way to simply guess is, so 0 to, if mod z is less than 0.5, right? So that can be, so z can be 0 to 0.5 or minus 0.5 to 0. Okay. So basically what you do is anything you want, say z less than mod z less than z, you need to symmetrically sum up the two sides. So it's precisely this thing. Right? You just fold back the triangles and add it. Okay, so this is the equation of this triangle. Okay, so now it's easy. You have everything in place, right? You have the density, you have the equation of density, and note that this is a positive number. Density is always positive. Z minus 1 is negative between 0 and 1, right? So negative times negative is positive. Okay. So fine, yeah. So this is a random variable you want to evaluate on the mean and standard deviation, right? So first take mean, right? So this is nothing but 2 minus 2z, right? So mean of z is this. Dz varies from 0 to 1. A simple integration will give you 1 over 3. So to compute mean, you need second moment along with the first moment, which is mean, right? The second moment is 1 over 6, and variance is nothing but your m2. This is 1 over 6 minus m1 square, 1 over 9. So that is 1 over 80. I think it was asked the standard deviation, but you can take the square root. Yeah, so square it, you will get 81 over 80. Okay, clear, right? Main thing to solve this question is easily is to identify that the final distribution of uniform random variables when you add it is nothing but convolution. Okay, cool. Can go to, yeah, this is quite complicated question. I mean, yeah. So I mean, question is complicated, but what they're asking for is not that complex. So some bus company from some place decides to start the service in this place, Bloshville and Blissville, sensing promising business opportunity. So Fred moved back to Bloshville. Now, when Fred arrives at the bus stop, either of the two independent bus lines make up. So the Blissville company bus arrival times are uniformly distributed between 0 and 10, and Bloshville company bus is exponentially distributed with um, 1 over 10. That means mean 10. Okay, so basically Fred arrives uniform randomly at a time. What is the probability that Bloshville company bus arrives first? So all you need to remember is the time of arrival of Bloshville is exponentially distributed random variable with this exp of lambda, which is 1 by 10 here. And Blissville company arrival is distributed uniformly from 0 to 10. Right. So what is asked is Bloshville bus arrives first. So what is the probability that this random variable is less than this random variable? We have seen a lot of this variation in our previous session. Right. So yeah, so we just define x as a random variable that is in our questions of this will, and that is uniformly distributed from 0 to a is 10. Okay. So I just took it a bit generic here. Y is Bloshville and that is exponentially distributed with lambda. The lambda is 1 over 10. We are asked this question, probability that y less than x. The same thing as what we have done last time. Probability y less than x, condition on x, and you sum up all the possible values of x. Okay. Here x is a uniform random variable. And the reason why this thing, probability y less than x given x is equal to x, is nothing but probability y is less than x because y and x are independent. Okay, that's why this quantity is replaced by this quantity here. And this quantity fx of x is nothing but 1 over a by definition of uniform random variable. Right? So yeah, I just mentioned here. And yeah, since x goes from 0 to a as it's uniformly random distributed random variable, right? Just expand it and substitute it, you will see this is 1 over e. Any questions in this? I mean, this is quite standard. The last time also we are seeing 2 to 3 questions like this. Okay, cool. So let's move to another question. Okay. Now x, y are uniformly random points in the triangle plane with vertices 0, 0, 0, 1, 1, 0. Find the conditional PDF of x given y. Okay, so let's see what it is. Um, so this can be solved in simple one line. We can solve it using the first principle. So this is the region, right? This triangle is the region that is given. Okay, this inside triangle. This is where the points are uniformly distributed. Okay, so this is x, y, and this is 1, comma 0 and 0, comma 1. And what they are saying is they're given a value of y. How is x is distributed? Right? So let's say any value y between 0 and 1 you take, how x is distributed is because it's said that it is distributed uniformly within this triangle, and you condition on y, along this line it is uniformly distributed. Okay. What is this line? Is nothing but x plus y is equal to 1. Right? So at till what point x can go? X can go from 0 to 1 minus y. That's it. So it is uniformly distributed from 0 to 1 minus y. Okay. So how do you do it by first principle? Okay. You are given f of x. You want to find f of x given y. So f of x comma y by f of y. What is f of x y here? Okay, this is x, this is y, and in the third dimension you have f of x comma y, right? So what is the value of that? Right, so that will be 2 because the entire volume should sum to 1 here. The area of this triangle times the height because it is uniform, right? So that will be constant, right? So area of triangle is half here, right? And so height will be 2. That's why f of x comma y is 2 in this region only, in this region, whenever x is in this triangle, x and y is in this triangle, right? So what is f of y? I want f of y also, right? So that's it. So f of y, you need to marginalize over x, right? And now, if you want to marginalize over x, x can go from where to where? Here in this triangle, x can go from 0 to 1 minus 5, right? So substitute that 2, f of x is 2. So it is you are integrating over dx. So it's a typo here. Please be mindful of this. Okay, and x is going from 0 to 1 minus 1. That is nothing but 2 into 1 minus 1. Okay, so this is valid in this region only when x is less than 1 minus 1. So just substitute these two things, 2 in this equation, like 2 by 1 minus 1. So, and you know the range of x. This is precisely a uniform distribution of x given y when x is going from 0 to 1 minus 1. Right? So value is 1 by 1 minus 1. Right? So this is another first principles way of solving the same. Okay. If this is clear, we can go to second. This, okay. Now we are given this question, another question as same thing, joint density, and we are given this k times x into x minus y, x goes from 0 to t, 0 to 2, and y is from minus x to x. Otherwise, it's 0. So, I mean, this is a very simple question. Just observe that. So, if x is 1, you don't even need to find ky basically. If x is 1, what is the value that y can take? Is minus 1 to 1, right? Because it is given that the density is in this range only. But what we are asked is, what is the probability that y is less than 1.5? Right? So maximum the y can take is 1, right? So you're asked what is the probability that y is less than 1.5, which is 1 actually. Okay, so you don't even need to put pen or paper also. You understood why it is 1, right? Yeah. Yeah, again, this is, yeah, this is a bit interesting, but not, I mean, it involves a lot of calculation. So we want what is the probability that x is less than y is less than z, where x is lambda 1 exponential with mean 1 over lambda 1, y is exponential with mean 1 over lambda 2, and z is exponential with mean 1 over lambda 3. Right? So the main crucial part here is to write this integral. The rest is all algebra. Right? So how do we write this integral is, here x is going from 0 to y, right? And y by itself, because x is less than y, this condition is taken care. Okay, x is less than y. Now y, how much it can go? It can go at max z. So y goes from 0 to z. So that is also taken care of. Y goes from 0 to z. But z is, we don't want to put anything, any constraint on z. The values that it can take on the higher side. So z goes from 0 to infinity. That's it. You need to keep integrating it. With this, you substitute this thing because they are independent, right? It's multiplication, joint density, and yeah, you just need to do some algebra and you end up with this expression. Actually, I did not simplify completely, but yeah, I just left it at this point. But the main thing is you should be able to write this. The rest is all straightforward. Right, so that is the most important thing. The taking proper limits is the most important thing here. And yeah, so this question is a bit tricky, I think, today in the overall whatever we are talking. So x, y, z are independently analytically distributed random variables uniformly from 0 to 1. So we want the joint density of the v and w, where v is nothing but the product of x and y, and w is z square. Okay, so what I did is first found the the density of xy. Then we use the transformation rule of this and, mapping one set of random vectors to another set of random vectors through Jacobian. Okay, so let's see the solution. Okay, so V is xy, right? So I just denoted V is xy, and we want to find the density of that. So first, for finding density, I go for distribution, which is nothing but this, the definition of distribution. Because it is continuous, I mean, let's find this n or less than or equal to is okay. And same trick, right? Condition on x, v is nothing but xy, and the condition on x and integrate it over all the possible values of x. We just expand this this integral inside this as this thing. So what is the probability that v is less than alpha given x? V is nothing but xy, right? So let's substitute that xy here. So y will be less than alpha over x, and given x. And you know that x and y are independent. That's why you write this as probability y less than alpha over x. Okay, so that's it. Substitute back, and this is what we get. Okay, is you simplified this to this. Yes, so yeah, x is uniformly distributed from 0 to 1, and this breakup of this integral is important, right? So if x is less than alpha, um, right? If x is less than alpha, this quantity is greater than 1, right? Alpha by x is greater than 1. Because y is uniformly distributed from 0 to 1, probability that y less than 1 will be 1, right? So that's why we want to split at the point of alpha here, right? And x goes from 0 to alpha and alpha to 1. Okay, so that's it. So because from 0 to 1 alpha, this value is 1, and fx is uniform from 0 to 1, that is also 1. So it is alpha here, the first integral. Second integral, probability y less than is some beta. If y is uniform, is nothing but beta, right? So that will be alpha by x. This term will be alpha by x, and this term is 1, right? And alpha by x, you integrate it over dx is nothing but alpha times log x, right? Going from alpha to 1, right? So what do we get is alpha minus alpha times log alpha. This is your distribution, right? Density is just differentiated and you get minus log alpha. Alpha goes from 0 to 1. Again, between 0 to 1, your this thing is positive. Minus log alpha is positive. Log is negative from 0 to 1. So that is fine. Clear, right, so far? This is all non-trivial, whatever we have been speaking. Okay, cool. Right, so finally, now it is simple. I call v hat as v and w as z square, and we know v is xy, the distribution of that we know that is minus log z, and w is z square, we know z is uniform, and we know that this Jacobian rule, right? F of your output variables is nothing but f of input variables times the determinant of Jacobian, right? So that's precisely how written. F of I hat w is nothing but f of your v and z, right? And v is nothing but minus log alpha, z is uniform, that is 1, and times the Jacobian, right? What is Jacobian is you just differentiate it by v hat, that is 1, and with respect to v hat is not a function of w, so that will be 0 here. Again, z, you need to differentiate it with respect to v hat here. Right? Z is only a function of w, that's why only this thing will have, because z is root w, tz by tw is minus 1 over square root of that. Just take the modulus of determinant, you get 1 over square root of 2, that minus minus log alpha. Yeah, if you can put it, want to put some v, you can put it. Mindful that alpha belongs to this argument and w is corresponding to this. Okay. Clear. Yeah. And we are given two independent random variables. One is exponential distribution, another is uniformly distributed, right? And you want to find the maximum of xy. And yes, so the answer here is not precise, um, because I mean, can you guess why this is not a valid density function? Because fz of plus infinity is not 1. Okay, so such trivial checks you should be able to do it by looking at by knowing things about the properties of the distribution. Yeah. So yeah, so maximum. How do you find the distribution of maximum function? The maximum of two independent unknowns. Its maximum. I'm denoting it by z. Maximum itself is lower than some z. So this x and y will be lower than, definitely lower than z, because maximum is smaller, right? Then because of independence, you can separate out these things, probability x less than z and y less than z, right? So again, right, if it is between 0 and 1, if z is between 0 and 1, this quantity is z. That's why first quantity is z, and exponential distribution is 1 minus e power minus z. So that's why it is this thing. And when it is greater than 1, z is greater than 1, this anyway is 1. This thing is 1. And yeah, you only have this thing, 1 minus e power minus lambda z. I think here lambda is 1. Okay, so that's it. If it is greater than 1, this is the distribution. And if it is less than 1, and this is the distribution. Clear? X and Y are independent. That's why this product is being separated. Otherwise, it's not possible. Okay. And yeah, this is one more simple tricky question regarding the order of integrals, right? So we have the joint distributed density as defined like this: e power minus u. Okay, it depends only on this argument u, but there is a region defined for all of them. Right? 0 is less than, x is less than, y is less than, z is less than, u is less than infinity. Okay, so we want, what is the marginal of x? We want to integrate out y, z, and u from this. Okay, so it's from the question you can see that u is greater than z, and z is greater than y, and y is greater than x. Right? U is greater than z, z is greater than y, and y is greater than x. Okay. So because u is greater than z, right, u goes from z to infinity, and z is greater than y, z goes from y to infinity, and y is greater than x, y goes from x to infinity. That's it. So first time when you integrate with respect to u, you get e power minus z, and second time when you integrate with respect to y, sorry z, you get e power minus y, and third time when you integrate with respect to y, you get e power minus x. So that's why the answer is e power minus. Why all integral? Because it is, they all have lower, they all lower bounded by 0 and among themselves. So u is greater than z and z is greater than y. Y is greater than x. The themselves can take any of the large values. So x can take 10 power 6, assuming. So y can just go above, at least take above that, right? But yeah, they are less than infinity. Yeah, that is a bit tricky. Depending upon question, you need to um, do this ordering thing. And what is we're coming to the last question of today. X and y are continuous random variables, and they have a joint distribution over the square. It's the square of side 4. And you were asked what is the probability that you are above some region, outside some region. So I just explained it clearly here. Okay, so this is the square that is being given, and this region is where your mod y is less than mod x plus 1. And apart from this region, you have this region where mod y is greater than mod x plus 1. Only this region is this thing. Sorry. All this region inside the square is this represented by this. So it's very simple because it is uniformly distributed, right? You just need to compute this area and total area, divide by the total area. Right? So the side of the square is root 2. So area is 2. 2 over 16 is this area. Probability of any point falling in here is this. And if it is lie here, if it is lying here, right? So the probability is 1 minus this, that's nothing but 4. Right? That's it. Except I think that log question, I think all of are pretty simple. So yeah, if you have any questions, we can discuss. Otherwise, we can call it off. So let me stop recording.